welcome back. We're going to talk about batteries again. And last time we talked about a battery having two different compartments that could hold charge. Today we're going to talk about a different kind of battery. It's a solar panel. And a solar panel is different from other batteries because instead of receiving electrical charge, what it is capable of doing is taking solar charge from the sun, for example, or some other light source, and translating that into electrical charge, which can then be used uh, to charge, for example, up a battery. So imagine that this is a solar panel, and once we got enough charge in it, we would start to see current flowing via a wire to a battery. So as long as the light was going into this panel here correctly, then we would expect to see uh, that electric charge flowing out of the panel into the battery. Now, one thing that can happen with these panels is we may not be facing directly into the light source. So if the light source is over here, it still has solar charge, but it's not actually making it to the panel and isn't making a difference. But if we tilt the panel a little bit and face it straight into it, then we can get almost 100% of that solar charge going into the panel and then out into the battery. So it's very important that the solar panel actually be facing directly into the light source or the sun in order to maximize the amount of energy that is being translated from solar charge into electrical charge and then going into the battery. The amount of power that the battery can produce is a function of how much electrical pressure or voltage it can operate at and how much current it can deliver, for example, to a battery when it's charging it. And the power is just that voltage or electrical pressure multiplied times its capacity for current, uh, which gives you a number which is called watts. So the electrical pressure is measured in volts, the current is measured in amps, and volts times amps equals watts. So when we say that a solar panel is a 300-watt panel, it could be that that panel has an electrical pressure when exposed directly to the sun of 30 volts and can deliver under that electrical pressure an electric current of 10 amps. So 30 times 10 would give you 300. Or it could be that it has an electrical pressure of 10 volts and has the capacity to deliver a current of 30 amps. Still, 10 times 30 would give you 300 watts. So the capacity of the battery is measured in watt hours or amp hours. So it will operate at a specific voltage and be able to deliver a specific current for a specific period of time. The capacity and power rating of a solar panel is measured in just watts, which is just the voltage or electrical pressure that it can produce when exposed directly to sunlight and the amount of current that it can produce to charge a battery.